Okay, so we're out here today working on some fence. This is not a replacement, this is just an improvement for fence. But we've got this permanent installation here of high tensile fence. I think there's 8 strands of high tensile, non-electrified. The problem with high tensile is cows that's non-electrified, is cows can come up and stick their heads through and eat on, get a bite of grass on the other side, and that stretches your wire. It loosens your wood posts, pulls the clips off the T-posts. It can even pull staples out of the wood posts. So you need a couple strands of electric on the inside just so that the cows get that little shock and stay off of it. We've tried various insulators in the past, and we're still kind of experimenting, trying to find what works the best. These little plastic insulators like this one. So we've used these and they have functioned for a while, but in the cold weather this plastic gets brittle and it breaks. So what we're trying now for this permanent installation is these ceramic with a lag type attachment that screws into the wood post, and the porcelain is still a brittle product. So these can break, but they're not affected by the cold. Tape measure here and pulling out, I'm going to scratch a mark at 2 foot and 3 foot. So that puts 2 hot wires right in the zone where a cow would stick its head through to eat. So that should be plenty enough to keep them off of it. One issue with these, where it differs from something like this, the hole is a solid hole. So when you go to pull the wire, you have to thread it through each insulator all the way from corner to corner. Whereas one like this, you can take the wire in and out, and that's where you're going to have an issue, is if one of these does break and then I can't replace it without cutting the wire and actually splicing it. And that's probably going to be the biggest downfall to this insulator, but we'll see how they hold up. Okay, so this next corner right here is we're not going to terminate at this corner. We want to go around that corner and go down that way, and we want to terminate down there on that corner, or that end brace. So this inside corner right here, we've got a different insulator set up. This is a Dare, and it's a high strain corner and end insulator assembly. So it comes with these L-shaped lags. They've got a lag on this end and a regular thread on this end. Came in a packet of 10 here, and it gives some specs here on the side. So if you're doing regular electric fencing like poly wire or poly rope, you need a minimum of 2 inches deep. So that's about the amount of lag thread that's on there. For high tensile electric, you need to run it in about 4.5 inches deep. So that would be up to, yeah, that's pretty much all the way in. Actually, about 4 inches is all you're going to have. So I would run it in on high tensile up to that point. From there, then you take one of these little plastic donut insulators, you drop it on, and then there's a lock nut. This is a nylock nut, so it's not going to back off on you, but you can thread that down and tighten it on, and then that lets your wire come in and bend and go that way. So we'll see how, again, we're all learning together here. So this is an experiment for us. So let's go let's go install a couple of these right here in the corner, and we'll show you how that works. So this is a corner, and I want to go in and split the corner. So you don't want to go in this way, because then your load is going to be pulling sideways. So if you went in like parallel with this leg of the fence, then your load is going to want to pull it this way. Same here, if you go in parallel with this leg, then your force is going to be pulling that way. So you want to try to go in exactly half of whatever you're halfway between your things, and that way that spreads the load so that it's just pulling straight out. That's the ideal direction to pull on these. If you've got side load, that puts a lot of strain on your lag. It's much better to just be pulling straight out. So I'm gonna go in, and I mean, you don't have to be super precise, just eyeball it as close as you can. And remember, we're going to have to do these in pretty deep, because we're going to have a fair amount of tension on this. So you need to drill your pilot hole relatively deep. And like my top one is getting kind of close to this brace right here, and there is a metal pin in this post that goes into the end of this brace to keep it from slipping out. So you might have to adjust your height up or down slightly to avoid any other fasteners or materials that you may have in your corner post. So I've got this now threaded in, and to straighten that back up, I'm just going to take my adjustable wrench and put it on there and tighten it up, and then just give a couple little pulls until I get it straight, and try to avoid damaging your threads here. That should be good there. And now, same as before, we'll just drop that on. And as you can see, we didn't damage the threads there at all. Now we'll just thread that down, just like we did the other one. Okay, so we're here now. I've got the first strand. We pulled the top strand first. It doesn't matter which you do, but we did the top one first. So I'm here at the termination point, and I've put my insulated tubing here and put the staple in to hold it at the location that I want. So now, again, you have to remember, first thing is to put these little sleeves onto your wire. And then you run your wire through your insulation tubing and wrap it around here just like this. And now you can put these little sleeves on. And then we can take our crimping pliers here and set them. That's the first one. There's the second. Now, I haven't driven the staple all the way up yet because I wanted to make sure that you know, I didn't need to slide the tubing to a different position. But that looks like it's going to be okay. So now I'll go ahead and set that just tight enough to hold it in place. We are going to retension this fence before we get done here. And before I retension any of the line wires, I am going to retension, add some more tension to the H braces at every point. This is now terminated here, so we can go back up to the other end and install our tensioning, our insulated tensioner on the other end. Okay, so I got our first permanent wire up here and tensioned up, and so you can see what I was talking about earlier with because the wire here, the high tensile line wires are on this side, so they're only about an inch and a half away from this wire. So I've got a special set of insulators that we got from this is the Lockjaws brand. We had showed these, or some from this company, in an earlier video of the T-post insulators. We kind of did a little bit of a review on those, but this is a extension type of insulator, and we picked some up a couple of years ago to show just for this purpose. So it looks like they go on like this, and then you're supposed to snap them into this other wire. There is, you can see the teeth here are offset to one side, so you just put them together so that they make like a straight ribbon, and on this side they've got an open channel. So then that goes over the wire, and then you rotate it and snap it onto the fence wires, to the line wires. And like I said, this wire here makes sort of like a hinge pin, so that can't pull off, but it can't push back either. Okay, so again, I'm just going to show you how you do it there. You can see the offset in the teeth, and you just fit it together so your sides are smooth, and then you just put it on your wire and hinge it, and then push it, and then push it onto the lower wire same way. I'm out here sort of continuing with this fence experiment and the permanent electrical on the inside of the high tensile. That's done. I've got 2 strands up, and all the insulators and everything are on. My tensioner's on here. There's the ceramic insulators right there, and you can see down there are the Lockjaws Extends 5.0 insulators that we discussed earlier. They sort of clip onto that wire and stand the electric wire away from the fence approximately 5 inches. Now, I have tested it out here at the far end, and we have full voltage, the same as what's coming out of the box, is transmitting all the way down here. And so I think we've got a good fence now. Again, this is an experiment. I'm going to try some other designs on other stretches of fence. In the meantime, this section here has now been electrified permanently on the inside. So we'll wrap this video here, and stay tuned. I'm going to do a whole series of experiments with fences and fence design, different types of fence, and where they are best suited and where they may not be suited. So if you're interested in learning about fence with me, then I would say continue to tune in. I'm going to try to make a playlist, and we'll discover what's the best together. So stay tuned for that. Thanks for watching.